This is our JetIt maintenance dashboard. Our tool is designed to streamline and visualize the history of maintenance about the many different planes operated by JetIt at various airport locations. In building our tool, we ran a regression analysis to determine the variables that impact total downtime hours, in which we concluded the type of aircraft and the airport location were the most impactful. Our tool is made for JetIt's maintenance employees as an informative tool they can utilize when determining maintenance downtime on an aircraft they're currently performing on. So getting into our tool, the first input the user may utilize is the aircraft selector dropdown box. This lists all aircrafts that JetIt is currently using in operation in the past aircrafts they have used before. For this demonstration, we'll be using the N420ME aircraft. The second input the user may use is the airport selector that lists all current and past airports that have been used. For this demonstration, we'll be using the KRDU airport. By inputting the desired aircraft and airport, the tool will pull from past data history and utilize the regression equation that was made to determine expected maintenance downtime. The estimated maintenance downtime is organized between the four maintenance types JetIt encounters: planned, scheduled, unscheduled, and excluded. Planned maintenance is the downtime due to manually identified modifications needed for improvement or operational maintenance levels. Scheduled maintenance is the downtime due to maintenance that is performed in regular intervals to help them maintain the aircraft in a serviceable condition. This can include systematic inspection and detection, replacement of items, calibration, etc. Unscheduled maintenance is the downtime due to maintenance performed to restore an item to a satisfactory condition by providing correction of a known or a suspected malfunction, usually in the form of a surprise malfunction and immediate response. Lastly, we have excluded maintenance, which is the maintenance tasks that are done simultaneously. All of these outputs are used in the metric of hours. These can be also converted to days. Our goal is to maximize the scheduled maintenance time while minimizing the unscheduled maintenance time.
Taking a closer look at our graphs, as earlier mentioned, this dashboard is designed to help the maintenance crew kind of figure out and configure and optimize their resources in order to not only keep these planes flying longer, but also to reduce any unfortunate mishaps. Our first graph here is a join function of our first two of our drop-down boxes. For example, here with our N420ME and our KRDU. As you can see, we have our label legend here of excluded, planned, scheduled, and unscheduled maintenance. For this plane, if we're looking at it just as it appears right here, our scheduled and excluded maintenance seems to be pretty predominant as well here. The goal of this graph is to show as our purple unscheduled maintenance bars as low as they can possibly be. We set this up so as to show not only just the sum of downtime hours of one graph, but of one plane, but also of many other planes as well. In our drop-down box at our aircraft here at our filter box at the top, you can add as many aircrafts as you would like, comparing different aircrafts between each other for comparisons to see if they're all meeting set regulated standards, if one is performing too poorly, if one is performing too high, kind of rule out and assess issues. Could be pilot error, manufacturing error, regulation errors, things of that nature. In addition, we have our axes here, kind of dictate what's going on. We have on our x-axis is our timeline. This, of course, can be augmented. Instead of just showing our 1 year example, we can show 1 month, a few months, a longer span of time, any span of time, kind of showing what we would like to accomplish in our intended timeline. We have here just showing kind of a year span. As you can see, we have just, I think, a few aircrafts here showing multiple different graphs going on. As you can see, this is kind of a model of what we would hope things look like, with everything kind of being as minimal as possible, with our scheduled and excluded maintenance kind of high. Excluded maintenance, while they are not as dire as unscheduled maintenance, they could be causes of concern. If there are random mishaps, we would like the maintenance crew to be able to handle it appropriately as well. In our legend here, you can kind of click and unclick whichever types of maintenance you would like to see or not see. If you wanted to focus on any one type or any few types, 2, 1, any of the 4, any amount of 4, you can do that as well here, as you can see. Kind of make it cleaner, kind of make it easier to read. Of course, again, yeah, just like that, exactly. We can change our timing. We have it here, entry date in years. If you want, like I said, pick the months in question, pick the years in question, things of that nature. Yep. So moving on to our second graph, all the fiddling tools there. Yep. Looking great. Moving on to our second graph. This one is a complete sole function of our airplane selector. As you can see here, this is our history of our availability for a particular time span. We picked here a 13-month span from 13 months from January 2021 to January 2022, based on the data based on the data we collected of the company. As you can see, our y-axis here is our operational optimization, how active our plane is, how fully operational it is against our timeline. As you can see for this airplane in question, we went from fully operational to a stark nosedive starting in February on the way to March. And then just as quickly went back up again and stayed pretty consistent, only to kind of come back down again in October. So as you can see here, there's some cause for concern for this plane in particular as to whether or not this is a cyclical error, cyclical issues that cause it to be so low in operational time. A factor and a nuance of our dashboard and how the data is set up here. So for ease of readability is that our different maintenances, they kind of run independently of one another. So unfortunately, our planes could be experiencing more than one type of maintenance at a time. For example, scheduled maintenance could be happening with excluded maintenance, could be happening with unscheduled maintenance. So some of our planes here unfortunately do have operational data that is even below zero, so as to show that there's multiple things happening on that plane to kind of make sure and help it get back on its feet as soon as it can, get back in the skies, as it were. But yeah, this is just something to kind of give the crew an idea of what they're dealing with moving forward. So if they encounter any new issues with any particular plane, they can understand, okay, is it cyclical? Are we expecting this at this time? How low how bad is it going to be? Things of that nature. The very nature of this graph is to help determine longevity. If a plane needs to be scrapped, it needs to be remodified, it needs to be, retired, things of that nature. The history graph, as well as, concurrent, all types of the maintenance as well, is definitely going to be a great factor and indicator of that. Going back to our estimated time required, our times of maintenance, that one is also a joint function of our airport and our airplanes. So as it is, we have multiple different fleets of planes, and we store them at multiple different airports. So when you kind of pick between these two factors, you kind of get a really good idea of what this particular airplane type is doing when stored, or how it's being operated on when it's stored at this particular airport. So it just has, like you said, any total collective raw data, raw number of hours. Again, this can be augmented and used for days, weeks, et cetera, et cetera. If these numbers ever show a zero or a negative, it's meant to just show that the plane itself isn't operational at this current point in time, or it doesn't have any data for that at that current point in time. So looking for only positive numbers, and those positive numbers will give us a good indication of what's happening, what we need to know for the plane. So we just designed this to give the maintenance crew a very, very good hands-on, very poignant approach and a way to kind of decipher and figure out what their planes need, when they need, and when they need what they need. Obviously, the point of JetIt is to offer privatized transportation at a moment's notice. So the goal here would be to maximize business efficiency, operational efficiency, reducing as many errors as possible, and of course properly allocating JetIt's limited resources in the best way possible. That's been our presentation of our dashboard.